All right, all right, all right. What's up, everybody? Welcome, welcome. Little weird technical glitch there as we were getting started, but we are good to go now. Great to see everybody in here. Thanks so much for joining us today on this beautiful Monday, December 9th, winding down on the end of the year 2024. Man, feels like it has just flown by, but we've also been able to accomplish a lot this year, so it's been a little bit of both. Those are kind of like the best kinds of ways to spend your time, where it feels like you're accomplishing a lot, but it also feels like it's going by fast. Time flies when you're having fun, as the old adage says. So I hope that everybody's having a good time on this beautiful Monday. We had a great weekend. We had some really nice weather here, especially yesterday. Man, it was beautiful yesterday. We got to go outside, spend some time outside with the kids, running around, playing some soccer. It was a good weekend and a great way to spend that beautiful day. Spend and enjoy that beautiful day. I don't know how many more of those there's going to be this season, so it's good to really get out there and enjoy them while you have them. And I think that everything is looking good for this stream. I think we have full connectivity. Let me just check my monitoring system over here. Yeah, everything looks good. All systems go. Everything sound good out there to you guys? Give me a 5x5 in the chat if everything sounds good and if everything looks good. If anything's too loud, too quiet, let me know that as well. But I feel like we got pretty much everything dialed in here. I'm going to have a sip of my delicious coffee. Oh, yeah, that's some good coffee today. Everything is great. All right, awesome. Nice. Omri, nice. 5x5, 25, exactly. You got it. Exactly. That's exactly right. And what's up to Aaron C? Thank you for joining us here today. And what is up to Rambro's Workshop? Thank you for joining us. Champ, the world champion of 3D CAD speed modeling, is here with us in the chat. FPV Kev is here, regular contributor on the Discord. Great to see you here in the live stream as well. Zayed Joe is here, recent CSWP training graduate. Congratulations, our most recent CSWP in the chat. Omri is here. What's up? What's up? Vicky Chong is here. Hello, Vicky. Hello, hello. Thank you for joining us. Great to see you out there. Parge is here. What's up, man? I saw you in the Discord this morning, and I thought, I'm going to drop this in here. Maybe he'll join us. And here he is. Welcome, welcome. Thank you so much for joining us here today. All right, guys, well, let's get into it. Parge has to leave soon, so let's see if we can at least get one challenge in there for him, old friend of the show. So today is Monday, December 9th. We're going to do some 3D CAD modeling practice, some 3D CAD esports, some CAD versus CAD action. We're going to have two speed modeling challenges. Actually, these are not tier 5 challenges today, but two fun speed modeling challenges. And we'll have some updates from TooTallToby, a live solve using Onshape, and of course, we'll hang out with the best chat ever. And so the live solve we're going to do is going to be this one here, this curved alignment post. This is one that threw some people for a little bit of a curve, because what we have found is that when you're working in Onshape, you don't have the option to do the sweep with the multiple guide curves. So we're going to show how to resolve this doing a loft with multiple guide curves. No problem. We just need to figure out where to place that second ellipse. And the way you figure that out is you make your guide curves first. That's the whole trick. Make the guide curves first, and that'll take care of you. Jim Yude is here, says, hi, new and excited to have found this. A big fan of the tournament and have been having a blast getting through them. Free CAD user and best regards from Sweden. Hello, Jim. Thanks for joining us. Great to see you here today. Glad that you're enjoying the tournaments. And if you like the tournaments, you're going to have some fun here today during the live stream. You get to see how fast you are against some of the fastest in the world. Even the world champion of 3D CAD speed modeling is here today. So it'll be a good one today. Don't forget to hit that like button before we get started, before we get into this first challenge. Don't forget to share and reshare as you guys are watching the live stream. And let's get into our speed modeling challenge. I'm going to show you a 2D print, and I'm going to challenge you to turn it into a 3D model as quickly as you can, and to calculate the mass of that model, and to enter that mass directly into the YouTube chat. And speaking of the YouTube chat, we got Bob Phelps here, says hello from Iowa. Hello, Bob. Thanks for joining us today. Great to see you in here. And the basic rules of this challenge are that you can use any 3D CAD package as long as you can input density and output mass, and make sure you use the specified precision, although today all the challenges are in whole numbers. The first person to answer correctly in the chat will be declared the winner. You can answer as many times as you want. We will accept your last answer in the chat. So if you realize you made a mistake, that's fine. You can go back and you can edit that mistake. And actually, I realized I made a mistake here on the PowerPoint. Let me just make a quick edit here. Quick edit, guys, on the PowerPoint. Oh man. Good thing I did that. PowerPoint actually just crashed on me. All right, so let's see here. We need to just quickly edit this. This will only take a moment, guys, but we got to make sure this looks good so that when we look back on it in history, people know what the correct date is. Aaron C says hello to Jim. Hello. Hello, Jim. Hello, Aaron C. All right, here we go. Let's get into this challenge here. Make sure you use the correct precision. First correct answer in the chat will be declared the winner. These are the materials that we use. So guys, if you've never done one of these challenges before, make sure that you take a moment and you note these materials. Make sure you note these densities. If you model these parts up in the wrong material density, then obviously the answer is not going to be correct. So make sure you just take a moment, make sure you've got the correct materials for your system. You can take a screen capture, use print screen, or use some other material. No red oak today. We will add red oak to this list shortly. No red oak today though, Aaron. And the advanced rules are this is meant to be fun and good-spirited. Occasionally, I'll make some mistakes. The drawings that I make are not to any specific existing standard other than the TooTallToby standard. So sometimes part of the challenge is just trying to figure out where all the dimensions are. But that's how it is in the real world too sometimes. And the Ivan exploit is permitted. We are just about done with that Ivan exploit video. Aaron, I know that I owe you an update on that video progress, so I'll get that over to you this week. I'll update the ticket in Jira, and then we will have that Ivan exploit video ready for everyone. It's almost done. We're really close to finishing that video, so we will definitely get that video out to you soon. But the Ivan exploit is permitted on these challenges, although I don't think you'll really need it today, so probably won't really matter too much today. All right, guys, let's get into this first challenge. As soon as we show the print, the challenge is live, and then the first person to enter the correct mass into the chat will be declared the winner. Yep, and Aaron C confirming, yes, coming soon, waiting for the update from me in Jira. All right. John is here in the chat. Looking forward to that Ivan video. Yeah, epic. Yes, it is indeed epic. I am also, everybody's looking forward to that video. Don't worry, coming soon. All right, guys, here we go. As soon as I show this challenge in the full screen, it will be live for all of you. So let me just flip over to full screen to make sure that everything looks good as far as how this is squared up. I think that looks pretty good. Maybe I can move this up a little. That's pretty good. Here we go. This first challenge begins in 3, 2, 1, go. What is the total mass of this multi-body part or assembly in XXX grams? You can see in the upper left, there is a bill of materials. You've got two different materials here, plain carbon steel, 7,800 kilograms per cubic meter, and ABS, 1020 kilograms per cubic meter. And we can see here that this model is called NJO 3D printer. What is the total mass of this multi-body part or assembly in XXX grams? It's kind of like a pen. It's like the head of a 3D printer, some type of a device here that we're looking at. What is the total mass of this multi-body part or assembly in XXX grams? Tier 3 model here. Kind of a cool model. It's got like some little finger grippies on the one side. They're not on the other side. And these two parts fit together. They fit together perfect. You can kind of see that in that section view in the upper right. They fit together perfect. There's no gap or anything. And it's got this cool vent feature in it that I like. Like circular and linear edges. Kind of cool. What is the total mass of this part? Maybe you want to view this thing in full screen on your computer to make sure you can see all those details. What is the total mass of this multi-body part or assembly in XXX grams? All right, guys. I'm going to take one more sip of this delicious coffee, and then we're going to move on. Welcome, welcome, those of you who are just tuning in. What's on screen right now is your very first challenge. But before you get started, take a moment and hit the like button. And your challenge is to take this 2D print, turn it into a 3D model, and then calculate the mass and answer the question, what is the total mass of this multi-body part or assembly in XXX grams? Tolerance is plus or minus 2 grams. Some fun details on this part. This part is called NJO 3D printer. All right, guys, and while you're working on that, we're going to go through and just give some updates from the world of TooTallToby. We've had a lot going on that you guys have seen. There's been a lot going on behind the scenes. Don't forget to like and subscribe. If you're just tuning in, be sure to hit that like button. Then you can get into that challenge. Subscribe, share, and reshare. Let your coworkers know what's going on in the world of TooTallToby. And, of course, above all else, be sure to take a moment and check out the Practice Models app over on the website. We've been doing a lot of work on that Practice Models app. We continue to update that Practice Models app. And one of the biggest updates that we've made to this app recently is the ability to retry a previous challenge. So now you'll see that if you go to TooTallToby.com, you go into the Practice Models app, you can get to it right here from this link right in the middle of the page. Once you go into that Practice Models app, you can see I've completed some of these practice models, and now I can actually go in and try again. We've got the try again function, so I can try again, try to get my time to be a little bit faster, maybe pull down the overall average time. Look at this, current fastest time. Rambros, the world champion, he's in the chat right now. He's got the fastest time on that challenge. But that is a huge update to the world of 3D CAD. You can try again using different CAD systems if you want. We're only capturing your most recent time at the moment, or sorry, your whatever time you want to save. So when you do it again a second time, if you want to do it with a different CAD system and then save that time, that's all we're capturing at the moment. But maybe we'll see in the future some more updates to help you with that, Omri, if you want to do it with different CAD systems. The Centennial Gamer says, is this the only challenge today? No, we are going to have a second challenge today. So if you got a late start on this one, don't worry about it. But it's all about practice. It's all about you guys getting the good practice in. So we are going to have another challenge here in just a little bit later today. So be sure to check out that Practice Models app. That is a great way to support the channel. You know, check it out, see what you think about it. And then if you really enjoy the app and you want to support the channel, you can click here for premium membership. You can sign up for the premium membership. It's another way to directly support what we're doing over here at TooTallToby. And man, Aaron C. already coming in with an answer. Wow, that is speedy. Man, wow. I'm not going to say if that's right or not, but wow. Centennial Gamer, is Fusion an accepted software? Absolutely. You can compete using any CAD you want, as long as you can input a material density and you can output the mass. You can use whatever CAD you want. So absolutely, great question there. And you can use any CAD you want on these practice models as well. Got a lot of good free practice models challenges here for anybody in the TooTallToby community to try. So check it out, practice models over at TooTallToby.com. This is where you can get even more 2D to 3D practice in. But yeah, to answer your question, as long as you, if you're using a different CAD system, if you're using Fusion, for example, make sure that you have the correct material density. The material densities are listed here on the screen, and that way you'll be able to grab and program in the correct material density so that you can calculate the correct mass. I'm just thinking Centennial Gamer's asking if Fusion is an accepted software. Not only is it an accepted software, but Fusion 360, our Fusion 360 user, Rambros, is currently the world champion of 3D CAD speed modeling. He battled through a tournament with 16 people from around the world, and he won the entire tournament using Fusion 360. So not only is it eligible, it's currently the winner. It's currently the world champion. So absolutely, Fusion 360 welcome. All CAD are welcome. And guys, Don't forget that we do have a donate function set up over at TooTallToby.com. If you do have the ability to support financially, we always appreciate it. One great way to do that is just to sign up for the Practice Models app. That's a great way to do it. Sign up for Practice Models, sign up for Practice Models Premium. But we do have some users who come in with a PayPal donation every month. They've set up a recurring donation. And I want to make sure that we give them a special shout out, a special thank you. So huge thank you to Dale W., to Sylvain, to Yup, That's Me, and to Martin L. Very, very much appreciate your guys' continued support. Really goes a long way to help us continue to put out the content that we're putting out, to help us continue to develop the app and really kind of embrace this idea of the gamification of 3D CAD. I think it's such a cool way to learn 3D CAD, to kind of go through and see a challenge and try the challenge yourself, and then to see somebody else modeling it, see an expert modeling it, doing a tutorial, learning some things that maybe you tried to do that didn't work out. It's just such a fun way to learn. It's such I think it's a great way to learn. And so I'm so happy that we've been able to run this channel as long as we have. I look forward to being able to continue to run it for as long as possible. And these are just some of the people who have kind of supported us along the way. Huge shout out to all these people, and really to everybody in the community. Everybody supports the channel in different ways. Whether it's sharing the notifications, sharing out that we're having a live stream today, letting other people know, answering people's questions in the Discord. There's lots of ways that people support the channel, and I really appreciate all of it. And of course, another great way to help support the channel is just working with me on an Ivan exploit video. That's another huge way to help support the channel. So there's lots of ways to help support the channel, and we really appreciate all of them. And huge shout out to these guys who have had that recurring contribution set up. It's awesome. And so what else is going on in the world of TooTallToby? Well, we did have some training last week. We taught our sheet metal training class. It was awesome. The students were really happy. We learned a lot about sheet metal. I learned something from one of the students, and I shared that in a video last week about my bend lines not showing up. So that's always good when you're an instructor and you learn something from one of the students. That's why we do it. It's a big reason why we do it. It really helps us get better as instructors too. So we are going to run that sheet metal class again next month. Be on the lookout for that. We're also going to run a SolidWorks beginners training class next month. So if anybody's interested or has coworkers maybe who are just getting into the world of SolidWorks, we are going to be offering a training class for them next month as well. Vicky just dropped a link into the chat so you can check it out. TooTallToby.com, TooTallToby.thinkific.com for the training resources that are coming up there next month for some of those classes. And when you take those training classes, you get a training manual, you get training files, and of course you get a certificate at the end saying that you were an awesome student. Also, for anybody out there who's interested in CSWP, we do have a CSWP training class coming up. That training class is going to, available online. So that training class is for anybody who wants to take it at any time. You can take it at your own schedule. It gives you everything you need to take and pass the CSWP. And like I said earlier in the chat, I mentioned that Zed Joe is in the chat and that he is our most recent finisher of the CSWP prep training, and also immediately went on to take and pass the CSWP. Not only pass it, but get a perfect score on his CSWP after taking this training. So definitely a great class if you're interested in getting certified in SolidWorks. And if you know somebody who's interested in getting certified, let them know about this class. Same link that Vicky posted a moment ago, TooTallToby.thinkific.com. Question came in here on the chat. Question was, if I draw apart an IPS, may I change the unit system to inch with one button, or should I change all the dimensions one by one? Asking for SolidWorks. Yeah, I mean, so what happens in SolidWorks is in the background, everything you're doing is actually in meters. Like it's solving in scientific notation, essentially, or scientific units or standard units in the background. Yes, in SI in the background. So it's, no matter what you're solving in, if you're solving in inches, for example, if you're solving in metric, if you're solving whatever, it's always solving everything in meters, and then it's just presenting it to you in the unit system that you are asking for. So if you modeled it in inches and then you need to change to millimeters, it's not going to work with just one click. Like when you change, if you modeled something as 1 inch by 1 inch and then you change it to millimeters, it's going to be 25.4 by 25.4. It's not going to be the correct size. It'll be 1 inch by 1 inch still. It almost sees it like it's a physical object. So you'd have to scale that thing down somehow. You could do, insert feature scale. That's one way you could scale down. If it's multi-body, you want to make sure when you do insert feature scale that you're doing it with the scale about the origin, not scale about the centroid. You could, if you need the sketches to actually scale down individually and have the dimensions scale down, there are some kind of hidden tricks you can use to do that, like Sketch Tools Modify lets you scale sketches and the dimensions actually scale down, as opposed to the scale tool in sketch mode that doesn't actually do it. But, you know, if you made it in the wrong units, you're probably going to spend as much time trying to repair it as you would spend just modeling it again. I would encourage you just to model it again, just speed model it again. And let's see here. Like at the deep level, it's all surfacing, but I would love to learn more about how things work at the lowest level, like boss extrude, just doing extrude and then capping the surfaces. Yeah, essentially that's what it's doing. I mean, that's what we talk about in our like beginner surfacing class, Aaron. Great question there from Aaron too, asking about, you know, kind of doing a deeper dive. That's definitely something that we could get into a little bit more in some of our other videos, kind of going like a little bit deeper on some of these features, really getting down to kind of how they're working in the background, or maybe like a little bit deeper into how some of the individual options are working. Yeah. But I mean, to give you a short answer to your question, yes, that's essentially what's happening. We actually do that in the beginner surfacing training class and in the live stream that we did on surfacing a little while back. That's what's happening. You're extruding a cylindrical cylinder cylindrical surface with no ends, and then you're capping each end. That's why you can take any model and you can do an insert face delete, and if you just say delete, what happens is it converts it from a solid to a surface body when you just delete one face, because now the surface is open. So yeah, that's what's happening there. Everything really is surfaces underneath everything. Another question came in there from Khalil. He said, what is the difference between scale respective to the centroid and scale respective to the origin? Well, if you have imagine you have two bodies. Imagine you've got, imagine you have two bodies that are like this. This is the upscaled version. Two bodies like this, right? And then you take those two bodies and you scale, and they're touching each other. They're coincident to one another. And you take those two bodies and you scale them down relative to their centroids. They're going to move apart from each other when you scale them down. So they're going to start here. You're going to scale about centroid. They're going to move apart from each other. So they're going to scale about their centroids. They're going to now no longer be touching. But if you had two bodies and you scale about origin, then they're going to scale about the origin together, and they're going to stay touching. So that's why if you have multi-body, you always want to scale about the origin or selected point rather than scaling about the centroid. Because if you scale about the centroid, then all of a sudden you're going to have all this clearance between the parts. So yeah, that's great question there from Khalil came in with that question. What is the difference there? Yep, that's what the difference is. Yep, no problem. Let's see here. Learning more about the details of how those features are actually programmed into the software would have great insight into the debug when features aren't working as expected. Yeah, to a degree. I get what you're saying. I'm pretty sure fillet is just doing a swept surface of an arc, right? No, that's not what it's doing. Good question, but that's not what it's doing. It's you get into that a little bit deeper when you look at the. It's really what it's doing is it's calculating the intersection of two faces at an edge, and then it's offsetting. So you have two faces that come together at one edge, and then it's offsetting back a certain distance. So like it's offsetting from this edge down to here, and then it's creating some type of a tangent profile between those two surfaces. So it's more calculating tangency than it is than like doing a sweep. It's more calculating offset and then calculating tangency. Because if you think about it, when you go into the fillet command, you could say that you want the fillet to be asymmetric. That's kind of how you can visualize this. So like when you go to a fillet and you say you want a fillet to be asymmetric, what you're doing is you're controlling how far that offset is. Like you're saying the offset in one direction down to the corner is a different distance than the offset in the other direction. So it's an offset from the virtual intersection more so than it is a swept profile. Yeah, it's a good question. It's a good way of visualizing it with the swept surface, but that's not really what's happening. It's more of a calculating a distance to the virtual intersection point and then generating a tangent surface off of that. And that tangent surface doesn't have to be an arc. It could be an ellipse. It could be a spline. It could be a conic. Like there's lots of profiles you can control when you're defining it's called a section profile of a fillet. Vicky's saying, dang, Toby, you're a true wizard. Yeah, it's nice when we talk about this stuff at home. She's really impressed with my knowledge of 3D CAD. Sweep has only one input. Sweep has only one input profile, which can change scale, but not shape. Loft has 2 or more. Yeah, exactly. So what's the difference between sweep and loft? Is this surfacing level? Question from Omri here came in. What's the difference between sweep and loft? Yeah, and I think Parj answered that really nicely. I mean, when you a lot of times you can use a sweep or a loft. Like a lot of times, because in some CAD programs, because you can have multiple guide curves for a sweep, you could use a sweep or a loft interchangeably as long as the shape itself is the same. If the size is changing, so if it's like an ellipse at the start and it's an ellipse at the end, but the size is getting larger or smaller, then you could probably use a sweep or a loft. But if it's going from an ellipse to a rectangle, then you have to use a loft. So if you want to think of it in 2 terms, shape and size. The shape is the ellipse. If it's an ellipse at the start and an ellipse at the end, the size can change. The ellipse can get larger and smaller during the sweep, but the shape is still an ellipse at the start and the end, so it could be a sweep or a loft. But if the shape changes, if the shape starts as an ellipse and ends as a rectangle, if the shape changes, then it has to be a loft. Now, sometimes you'll choose to make it a loft even if the shape doesn't change. There's a lot of reasons for that, but that's the big difference. That's the main differentiator. If the shape is changing, it has to be a loft. You can't do it as a sweep. We're gonna have to just do a Christmas special where it's just like answering tech questions all day. I would love it. I would totally be into it. Can a straight line also be an arc with an infinite radius? I mean, you get into that's when you like really start talking about curvature. And that's what curvature 0 or curvature infinity would be, or arc radius of infinity would be curvature of 0. So yeah, you really start getting into curvature there. But then you also, then you start running, Bob, with this question, then you start running into like, what's the largest number that SolidWorks will account for? Like there is a limit as to like there's modeling limits. I think it's like 1 kilometer in each direction off the origin. So like 2 kilometers total off the origin. So like there are limits as far as how SolidWorks will actually calculate what's the biggest number that you can actually input into SolidWorks. What's the smallest number? I think the smallest number is like 8 decimal places. So you can't go further than 8 decimal places, something like that. Put a 1 in the chat if you want to do a Christmas special with Toby. Yeah, that's what we need. We need a Christmas special. All right, guys. Here we go. Let's continue on here. If I missed any questions, just ask the question again, tag at TooTallToby, and I'll see it. I don't want to miss any questions. This is my favorite part about doing these live streams is interacting with the best chat ever. So it's very easy for me to start getting into these questions, and before you know it, it's 2 o'clock and the live stream is over. So we want to make sure that we interact as much as possible. But of course, the other thing you can do if you ever want to interact with me is you can join us in the TooTallToby.com/training. You can sign up for some training. You can visit us at the Thinkific site, and we've got lots of options there on the Thinkific site. And then finally, I just want to remind you again, if you're looking for a good, easy way to support the channel, check it out. Check out the Practice Models app. You can visit us at TooTallToby.com/practice. We looked at it a little bit earlier. TooTallToby.com/practice. We're adding new features on there every week. We're adding new features. Every couple of days, we're adding a new model. And the most recent new feature that we added is the ability to try the model again. So this is pretty cool because you can really, ultimately what you want to be doing here, I think, is trying to just get under the average time. So if you do a model, you come in above the average time, just try it again until you get under the average. And that's a great way to kind of track yourself and see that you're improving relative to the field. A really, really great exercise, and it's kind of a fun thing to do. I do this sometimes too. I just try to get faster and faster on these models. I actually posted a video last week. I don't know if anybody saw it on modeling up the one sheet metal challenge. And then at the end, I do it again, just like no talking, just straight through speed modeling to see how fast I can do it. And it's pretty fun. It's pretty fun to go through and see if you can do it without making any mistakes. And it's another great way to learn. You really start to learn some things to look out for. All right, guys. Huge shout out to Bodie McBoatpants. Thank you, Bodie. If you're out there watching, thank you, my man. Making all my dreams come true. And let's get into it here. Don't forget to like and subscribe. And let's take a look at this first challenge. Now, where did this first challenge come from? Let's just talk for a minute about where this first challenge came from. Well, this first challenge came from our new option that we have underneath the YouTube channel called Join. So if you go underneath the YouTube channel called Join, you can see that there's 2 levels. You could buy me a seltzer water, and you know I love seltzer water. I drink seltzer water all the time. I think seltzer water is fantastic. So you can if you take a look underneath the YouTube channel, there's a button there that says Join, and then there's a couple of different levels you can join at. And one of those levels is buy a seltzer water. The other level is I think there's a level there for buy a coffee. And part of the benefit of buy a cup of coffee is that we will create a special model for you. And I just wanted to show you what that model looks like. Give me 1 second here. So for today, this model that you guys just modeled came from one of our users, came from our user NJO. And NJO signed up for that buy a cup of coffee membership level. And you can see here, this is on one of the videos on the NJO YouTube channel. So you can see here that this YouTube channel is the it's a 3D printer, believe it or not. This is the tabletop, and it's like a homemade 3D printer. It looks like it's got almost like a tube clamp here, and it's got this wooden table, probably made out of red oak, this wooden table here for the bed for that 3D printer. So on the NJO channel, it looks like maybe he created his own custom 3D printer, and that's where this model came from. So when people join up for that buy Toby a cup of coffee level, you get to support the channel, you get custom emojis, you get a personal practice model. So we'll add that practice model. You know, every week when we do Model Monday Live, we add another one of these practice models. It's been a pretty fun program. Aaron C said this is an absolute winner, and this is definitely what we should be doing here. So huge shout out to Aaron C for making this happen as well. And so if you sign up at TooTallToby or on the YouTube channel, if you use that join option, you can become a member. And and I'm just going to ignore the OF comments in the chat because I don't want this live stream to get flagged. So let's keep it clean out there, boys. So you can see here that Rich Penn joined us here at the Buy Me a Cup of Coffee level. Bob joined us. Dom joined us. Each time one of these people joined, we created a special episode on Model Monday Live where we created a special challenge in honor of them joining. Min Wantex joined. Fully Defined joined. We had Aaron C join. We had Victor K join. We had PC Arduino join. Yup, That's Me joined. And now NJO has joined, and each one of them has gotten a special model. This week, we're going to see some new videos go out where we're recognizing this new special collection of models. So we're going to get that out. We're going to start releasing those videos before the new year as well. So really, really fun program so far. And thank you all so much for joining and supporting the channel this way. This is another great way to support the channel. You get a special model created for you, a special challenge created for you, and a video dedicated to that challenge, which again is going to start this week. So this one here came from NJO. It's called NJO 3D printer. And let's take a look in the chat and see who got this answered first, and we'll see who got it answered correctly. So it looks like the first answer that came in here, let's scroll up here. We had a lot of talk there. The first answer that came in here came in from, let's see here. Did Parge come in with this one? 305.811. Thought there was one a little earlier. Aaron C, here we go. 305.818. Parge coming in 305.811. Ram Bros Workshop 173.5 or 0.49. Let's see what else we got in here. Who else came in with an answer for this one? A lot of chatter this time. Ram Bros revising 1 to 173. Let's see what else. I want to make sure I don't miss anybody here. A lot of people saying we need to see a Christmas special. I like that. Parge coming in. 173 is the most popular in the chat. Just curious how it went from 305 to 173. 173 has me nervous now. Rambros, both guys 173 were my answer. Parge 173. Let's see here. Aaron C. All right, guys, let's see. What is the correct answer for this one? The correct answer is 306 plus or minus 2 grams. So it looks like it is Aaron C. It's a good job that you stuck to your guns. Although I guess, Aaron C., you did say 173 in one of your comments, right? You said, I'm worried about 173. Seeing all these 173s has me nervous. I don't think that was considered his submission, though, for an answer, right, chat? So let's see here. We got Aaron C. coming in with the first answer. His answer was 3. Can't find it again here. 305.8 or 306 grams. Congratulations to Aaron C. Remember, this thing is made out of two different materials. So the lower part here is made out of this plain carbon steel. The upper part is made out of the ABS, 7,800 kilograms per cubic meter versus 1020 kilograms per cubic meter. So GG to Aaron C, guys. Let's give Aaron C a GG in the chat. He's going to find a new point on the Model Monday Live leaderboard found over at TooTallToby.com. That's your big perk from winning your points for this year, and we'll tally them all up, and we'll see who got the most points throughout the year. But GG to Aaron C. Congratulations. And with that, we are going to move into another challenge here. We're just going to jump right into the next challenge. So you guys said you wanted a Christmas special. Well, I was thinking kind of the same thing. Here we go. Let's flip over to the second challenge. Challenge number 2 begins in 3, 2, 1, go. What is the total mass of this multi-body part or assembly in XX grams? Tolerance is plus or minus 1 gram. And this model has 3 parts in it: a ball, a hook, and a lid. And this model, all parts are made out of ABS. And I thought this would be a fun one because you could actually 3D print this model. That's kind of the idea behind what I was making here. Now, I haven't 3D printed mine yet. I'm gonna give it a try and just see if my printer can handle that 2mm wall thickness. You'd probably want to print the ball down so you don't need any support, and then you can see if see if your printer can handle that. See if your printer can handle that ball with the 26mm diameter face down, and if it could print the whole thing without support. That'd be pretty cool. And then the other 2 parts, you can use your best judgment on how to print them. Probably the lid face down and then the wire. I mean, you could probably form a wire like that out of a coat hanger if you wanted to. But the wire, you can print that however you want. But I thought this would be kind of a fun thing. You could 3D print your own ornament. You could maybe add some text to it, make it something custom. And then if you're using a tree this year, you could hang that on the tree, and you'd have yourself a nice little festive holiday 3D printed ornament. So I'm going to give you guys a couple of more moments to take a look at that challenge and take a screen capture. All parts are made from the same material, ABS, 1020 kilograms per cubic meter. And good luck to everybody on that challenge. And with that, we're going to move on to a challenge of our own. I'm going to take a sip of my delicious pink lemonade Spindrift seltzer water. It's a little bit different from seltzer water. It's like more flavored seltzer water. It's Spindrift. I'm not sure how I feel about this. It's good. Feels like it's too good to be true, to be honest. There's got to be some water in here. Spindrift, not a sponsor of this show, but they should be. Really, Waterloo should probably be the sponsor of the show. That's what I drink the most of. But don't forget, guys, if you want to support the channel, you could buy me a seltzer using the join option down at the bottom underneath the chat. There's a join level for buy a seltzer, I think. Wait, let me look real quick. Look at my monitoring. Join. Buy me a seltzer water. It's there. Nice. Very nice. All right. Here we go. Let's get into it here with a challenge using Onshape. I love Onshape. My favorite 3D CAD modeler. Onshape modeling up this model here in plain carbon steel. We're going to do what's called a live solve, where we're going to go through and we're going to try and solve this thing right here, live on the channel for all of you, right in front of everyone, using Onshape. So let's get into it here with today's live solve. Good luck to all of you trying to solve that tree ornament speed modeling challenge. We'll see who comes up with the correct mass first. And while you're working on that, I'm going to try to work through this Onshape 3D modeling challenge. And so whenever it comes to a modeling challenge like this, the first thing that I do is I look at the model, try to kind of get my bearings as far as my game plan goes. You know, look at the title block, see what kind of material we're using, what type of units we're working in, so we don't make any, so we start off right away using the correct units. So MMGS, plain carbon steel. And then from there, what I look at is, as far as my game plan goes, what I try to figure out is where will the origin be located? And to determine where the origin will be located, a lot of times you want to start asking yourself, what's going to be my starting plane and my starting profile? In other words, where will my first sketch be? And that's often based on where a lot of dimensions exist, where there's a lot of dimensions coming together. It could also be based on whether or not the part has symmetry. And it could also be based on what the footprint of the part is, like how it's going to mount onto the assembly or onto the table or whatever it is you're working with. So in the case of this model here, I can see here that looking down from the top, this shape here is my footprint. I can see that this shape here is symmetric, it's centered. I can see that there's a lot of dimensions that seem to be coming kind of from that centered area. So I think it makes the most sense to have this as my starting profile, meaning that's going to be my first sketch. And then as far as where the origin is located, I think the origin could be located maybe up here at the nose, or it could be located back here. Either way, I think that's going to be fine. And then as far as where the origin is located over here, I can see that this 80 dimension is representing kind of the top of the slot or the bottom of the base plate. That's probably a good spot to have the origin as well. So I think that my final decision here is going to be that the origin is going to be right here, and then my first sketch is going to be this kind of home plate looking polygon here. So then after we decide on what our starting plane and our starting profile are going to be, we want to ask ourselves kind of what's the order of the features for this challenge going to be. So I'll start out with my first sketch here, you know, extrude this thing down. I'll probably just extrude it all the way down to the max height, which is, looks like it's going to be, I guess it's going to be the 12 plus 6. So I'll just extrude that all the way down to that 18 millimeters. And then after that, I'll add in this little cut here for the slot. Add that little cut there for that slot. And then after that, I can add in the, I'll probably save the counter bores for the end. So after that, I'm going to be faced with this challenge here. And we're going to do this challenge here as a loft. And the reason we're going to do this as a loft is because we've got two guide curves that are essentially defined here on the front view. We've got this shape here, 125 is a guide curve, and we've got this shape here defined as a guide curve. And in Onshape, we can only have one guide curve or a path when we're working with a sweep. We can't have multiple guide curves with a sweep. So instead, we're going to do that as a loft. And so in order to create those guide curves, we're going to need to create this shape here first. And then once we create that shape, we'll know where those guide curves need to go because there's a dependency of tangent here on that upper shape. So just to kind of quickly review our game plan here, we're going to start out by creating this shape, the base plate shape. We're going to add in this slot here on the bottom of that base plate shape. We're going to create a circle up here and extrude it in 2 directions to create this upper shape here. And then we're going to create that elliptical shape using a loft command. Once we have that, we'll be ready to cut this, cut extrude this hole here, and then cut extrude these counter bores or use the hole command to create those counter bores. So that is our game plan. Let's launch Windows snipping tool here so that we can grab a screen capture of this model. So we're going to grab a screen capture here, move this over onto our second screen, and let's move Onshape here onto our primary screen. And if you guys ever want to try Onshape out, you can use onshape.pro/TooTallToby. You can get 6 months of Onshape for free for you and your company. So kind of a cool promotion they're running there. And let's go create, and we're going to create a new document here. Now, this is a document that I'm creating in the public space. So if I wanted to go into that public space and search and see if anybody else has done this already, 24-08-17. Let's see if anybody's done this model before. And it looks like there are a few people who have done this curved alignment post, curved alignment post. So I could open up somebody else's model here. Jamie McDonald, he's always at the top of our leaderboards. So I could open up somebody else's model here who's already done this curved alignment post and kind of look and see if maybe I'm missing something, if I'm getting stuck. That's the cool thing about working with Onshape is you can look in that public space and see if anybody else has done this challenge, and then open up their model and kind of dissect it a little bit, figure out where you're getting stuck. But I'm going to go up here to Owned by Me, Create Document, and I'm going to call this thing 24-08-17 Curved Alignment Post. And let's flip over to our keyboard cam. Here we go. And now we're going to start modeling this thing. Again, we can go up here to workspace units. Just at the beginning of the project, if you're not sure, you go to this little hamburger menu, workspace units, and then you can see if you're working in the correct unit. So I can see I'm working in millimeters, I'm working in grams. So that is correct. I'm going to go top plane. I'm going to right mouse button and choose new sketch. I'm going to press N to get normal 2. And then I'm going to press the S key and I'm going to create that kind of polygon shape that looks like a home plate in baseball. So we'll move this over here like so. Bring a line over here. Now for this line, I'm going to press Q, and what Q does is it changes that line to construction, and that way I can just put a window around everything here, and then I can choose the sketch mirror command and mirror that down to the bottom. And then I'm pressing the S key to bring up this menu here. So S key, and we'll say that we want this to use a distance of 112 total. We're going to say that we want it to use a distance of 84 in this direction. We're going to say that we want this angle here to be 45. And we're going to say that we want the width at the nose here to be 40 millimeters. Now, we could certainly put in additional information in this original sketch, but I'm going to try to kind of keep things simple here. So I'm just going to do S key extrude, and then I'm going to bring that up, and that's going to come up to a height of 12 millimeters. So that kind of base plate shape is 12 millimeters. And then I could pick this face here. I know before I said I was going to do this with a cut extrude, but I think maybe what I'll do is I'll just take all this geometry here. I'll choose convert, and then I'll just create a couple of lines here. So create a line there, S key, create a line here. So I did I used the bottom surface there, started a sketch on that bottom surface, and then I used this command, use project convert, and that traced that entire bottom surface. And then I just sketched a couple of lines. And now all I need to do is add the dimensions to those lines. So actually what I should do is just have one line and then a center line here, because it's a total distance across. And then I'll take this line and this center line here, and then I'll choose mirror. And now I can do that total distance across, which is, oh, I was wrong. It's 12. I should have just left it as 12 and made it on 12 on each. All right, and now I've got that shape. Now I can do S key extrude. And now currently Onshape is picking this entire shape here on the bottom of the model. So I'm going to press the space bar on my keyboard. That clears all those selections. And then I'm going to pick this region here and this region here. So that space bar to clear your selections, a very helpful trick in Onshape. So that's going to come to a depth of 6, and I'm going to press enter, enter, and there we go. There's our first two features. So once you've got those first two features in place, now you're ready to start getting into kind of the more tricky area of this model. So I'll just slow down a little bit. I'm going to go here to the front plane, S key, begin a sketch, N key for normal 2. N is the shortcut to get your view to go normal 2 when you're working in a sketch mode. So I'll click here, I'll press N, get normal 2, and then I'm going to press the S key and go to the circle command, and I'm going to create a circle here at a dimension of 44 for the diameter of that circle. So 44, and then I can just add a couple of dimensions here. So S key to get to the dimension command. This is going to be from this line, from the bottom of the base, 80 millimeters to that circle, and it's going to be a dimension from this location here, maybe from this edge to the center of that circle at a distance of 33. And then I can take that circle and I can choose to extrude that circle, and I'm going to press tab, 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 and then I'm going to say that's going to come out to a distance of 28, and then tab, 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 and then space bar for symmetric. So instead of, going over to the property manager with the mouse, I just like to use the tab keys to advance through. If you like using the tab keys and the space bars instead of using the mouse, hit the like button on this video. Definitely a good shortcut in Onshape. So I'm going to press enter, and there we go. That finishes that extrude command. And now those are not connected, so I actually end up with two separate parts down here in Onshape. But in just a moment, we're going to merge them using the loft. So now I need to create the guide curves for the loft, and we can make both of these in one sketch. So front plane, I'm going to press the S key, begin a new sketch, press the N key to get normal 2, press the S key, get into the arc command. This one's going to start right here at this corner, and it's going to come up and get tangent, something like that. And then this one's going to come up like so, and this one's going to have a radius of 125. So now I can get in there and start adding some relationships. Pick this edge, pick this point I, the I key for coincident. Pick this point here, pick this corner I, the I key for coincident. Pick this arc, pick this vertical line here, T for tangent, T for tangent. I could move this over here. This ellipse on the bottom here is going to have a total distance of 66.6, or 66. So 66 for that ellipse on the bottom there, 66. And then I can pick this point here, this arc, I for coincident, this arc here, T for tangent, and then the same thing on the bottom. This point, this arc, I for coincident, and this arc, T for tangent. And so now we see that sketch is fully constrained. It's all black. That's what we want from our sketches. We're going to exit that sketch. Now we are going to be using this as our guide curve. So if you wanted to, you could rename this sketch before you leave. Call it something like guide curves Okay, and then hit the green check mark, get out of that sketch. And so we renamed it there before we actually exited. So then what we can do is we can go here to this top surface, S key, begin a sketch, N key, get normal 2, and here under the circle flyout menu, we can choose ellipse. Now, one little trick that I like to do with ellipses is if I know I'm gonna be piercing, I will use this command here, point, and just drop a point exactly at the quadrant point. It just kind of gives me a little bit of reassurance that the pierce is going to be in the right spot. So I just kind of drop in that point there, and then I can take that point, take this arc here, and then I can use the relationship of pierce. Pierce is hooked to Shift G as far as like a key binding goes. The only reason I remember that is just because I use pierce so often. It's such a useful sketch relationship, especially when you're sweeping and lofting. So this point here, this arc, remember, it's always a point in the sketch and then an arc outside of the sketch, and then Shift G for pierce. Hook them together with a pierce constraint. Whoops, looks like I got an inadvertent horizontal here. So just click on that relationship, press delete, and that will fix everything up. Delete, there we go, it fixes everything up. And then finally, the ellipse has a constant profile width of 18 millimeters. So now what I'm going to do is I'm going to create a dimension here, pick the ellipse, and then just move over here and type in 18 for that dimension. So now we're basically going to do the same thing on another plane up here. And so to accomplish this, we're going to hit the check mark. We're going to go to our plane command to create a new plane up top there. Now, to create that plane up top there, what we're going to do is we're going to press the S key. After we press the S key, we're going to choose the reference geometry plane command, or you can choose the plane shortcut up here, plane, and then we're going to choose an arc, and we're going to choose the end point of that arc. And that gives us a plane running perpendicular to that curve at the end point. And so now we can hit the green check mark, and now we can choose that plane, S key, begin a sketch, create an ellipse. I'm going to go through this a little faster because we just went through it a moment ago. Create a point that is at the quadrant point of that ellipse. Create a point that is at the quadrant point of that ellipse. Take that point, take this line here, or this curve here, Shift G, that's your pierce constraint. Take that point, take this curve here, Shift G, that's your pierce constraint, and then S key, smart dimension, click on the ellipse and give that ellipse a relationship or dimension of 18 for the constant width. And so now that we've got those two sketches, the ellipse down here and the ellipse up here, now we can take those two sketches and we can loft them together. So here in OnShape, we can choose loft. We can choose to loft this sketch to this sketch. If you can't pick it, you can either pick it from the tree or you can use the tilde key on your keyboard. Then that'll let you kind of pick through that solid geometry, that tilde key. And then what we're going to do is we're going to go over here to our guides and continuity, and then we're going to choose this as a guide, and we're going to choose this as a guide. So guides and continuity, and whoops, I'm getting an issue there with the end of that curve. Oh, it looks like that curve doesn't actually run. Let me think, how would I do this? I think I need a plane that runs through both of those points for that other loft profile, huh? All right, let me get rid of that. So now you can see I'm only hooking onto that one loft profile. So I think what I actually need, let me just think here for a second. I actually need a plane. I need to create that plane a little bit differently. So instead of creating the plane normal to that curve at the end point, I think what I need to do is, let me roll back here. I think what I need to do is I need to create another a line connecting these two guide curves. So let me go into that guide curve sketch. I'm going to create just a line here that goes between those 2 points. I think, just to be clear, I think that what's happening is the plane that I created is perpendicular to this curve, but I don't know if this line here would be perpendicular to that curve. The line that's connecting those two endpoints is probably not perpendicular. So therefore, the plane that I created it's probably kicking off a little bit like this. And so then when I created the ellipse over here, this guide curve isn't actually running up and touching that ellipse. Now I could extend that curve, but then my ellipse is not going to be tangent to this profile here, and that's the design requirement from the customer. So instead, what I'm going to do is I'm going to make a new line here on that set of guide curves, and then that next sketch that's created is ellipse down here. Then the plane is created. Well, instead of the plane being perpendicular to this curve, I think what I'm going to do is I'm going to say edit, and I'm going to change the definition of this plane. I'm going to change it to line angle. So now I could pick this line here, And I can say the angle is going to be 90 degrees. Or, okay, 0 degrees. There we go. So pick that line there and then say the angle is 0 degrees. And now I've got a plane that's perpendicular and that's touching at both of those endpoints. So let's see if that fixes the issue. So now we roll forward. So the sketch of the ellipse that's up here is now on this plane, still on plane 1, but plane 1 has been redefined. And then let's roll forward to the loft. And now to edit that loft, what I'm going to do is I'm going to double click on the loft. And then I'm going to come down here to where it says curves. And now I'm going to choose that second curve. Ah, still not working. Don't like that too much. Let's think here if there's anything else that we could think of that we're missing on that one. Man, that's a bummer. Let's think. Maybe if we change the order of this, if that would maybe make a difference. Let's see here. We're going to go pick this one first. Is it maybe it's like somehow twisting because of how I selected them? That one, and see, it's that one. That one doesn't like that path, but they're touching, right? They got to be touching because of that new plane that we created. Is it? Oh, I wonder maybe if it's the order of the guide curves. I wonder if the way the guide curves are solving. Ellipse endpoint is not on the guide curve. Yeah, it's on the guide curve. I'm pretty confident of that. I wonder if maybe we could troubleshoot here by. I got that second one wrong. It's not that whole thing. Let's see. Profile is going to be this and this. And now even with no guide curves, we're not getting anything. That's not good. I wonder if let me just hide this body here just to make it a little easier for me to troubleshoot this. Man. Let me just try one last thing here, guys. If this doesn't work, this might be a rare occurrence here. We're doing a live solve and we just can't get it to solve. I might have to just make this as an offline video. Man, all right. Well, listen, just because we're running up against the total time here, there must be something that I'm missing here, and I hate to abandon this effort, but I also don't want to run over time. I know there's some people here that have kind of a hard stop at 2 o'clock. So let me just because I'm nothing if not persistent. Let me just try this one more time. I'm going to make an ellipse here on this new plane that we created. I'm going to drop in some points here at the quadrant points. So drop in a point here at the quadrant point, drop in a point here at the quadrant point. I'm going to take this point and this curve and pierce them. I'm going to take this point and this curve and pierce them. And then I'm going to create a dimension here between these two. And guys, if you do have to go at 2 o'clock, I really appreciate you tuning in. Thank you so much for joining us. And be sure to hit the like button before you leave. And we're going to have that answer momentarily here. But let me just see here. So I'm going to make that 18. And now we're going to loft. I'm a little concerned that the loft isn't working even in this situation. Okay, now we're seeing some twisting. So that might give us some insights here. So let's see if I pick the loft. Okay, so now the loft is working. And now let's go down to our connections here. Let's pick this first one. And it errors. Let's pick this second one, and it still errors. Let's get rid of this first one. Still errors. Let's get rid of the second one. Okay. Wow. Is there any like condition or anything on this guide curve that could maybe be adjusted? Oh, wait. I'm in connections. That's why. Guides. Okay, here we go. Guides. Okay, pick the first one. It worked. Pick the second one. It worked. Okay. All right, there we go. Like I said, I'm nothing if not persistent. I don't like it when it doesn't work when I think it should, but I feel like I'm doing everything right. I think there must have been some kind of a selection I was making in there. Yes, Will Hod says it best. Yeehaw! That's right. We got there. All right. That's what we wanted to see. So there is our loft, and when we created that loft, what we could do is we could define that loft as saying we want to add, and then down here in the merge scope, we could say we wanted to add using both of these bodies here. We hit the green check mark. There we go. Now we've created that loft. Pick this face, S key, begin a sketch, N key, get normal to, S key, circle. Hold our mouse over that edge, wake up that center point, move our mouse out, single click, type in the diameter of that circle, which is a diameter of 22, S key, extrude. Go down here to our end condition, make that through all, hit the green check mark. There is that hole. Whoops. That should have been a remove through all. There is our hole. And then pick this face here, S key, begin to sketch, get normal to. We're going to create a center point rectangle from this area here, kind of aligned with the origin. And it's going to have the dimensions of 30 by 65. We're going to create a dimension here coming off of the edge of the model to the beginning of that rectangle. That dimension is going to be 12. We're going to exit that sketch. That's going to be our sketch for the holes. We're going to click hole here, counter bore. The counter bore is going to have a through diameter of 9, tab, 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 16, tab, 6 for the depth. And we're going to go here to our points, 1, 2, 3, 4 points there from that rectangle sketch. Hit the green check mark. We're going to press P to hide our planes, Shift P to hide all of our construction geometry. Give this thing the final spin. It looks pretty good. We're going to come down here to the name of the part down at the bottom. We're going to say edit appearance, make it a little bit more blue so it matches up with what the customer has. So when we go into that customer meeting, what they see on their print looks just like what we're showing them here. We're showing them that we care, that we're taking care to show attention to detail to match up with their print. And then we're going to right mouse button on the name of the part and say assign material. This is going to come from the TTT material custom library. It's going to be plain carbon steel. We're going to hit the check mark. We're going to go down here to our mass properties option, and we're going to click on that body, and we're going to see a mass of 1496.3, and we're going to return to our challenge here in PowerPoint. Let's type that into the chat. 1496.3 grams. We're going to enter that into the chat, and then we are going to return to our PowerPoint here, and let's see if we got it right. And the correct answer is 1497 plus or minus 2 grams. So we did it. First try, no problems along the way. And that is how you could troubleshoot a challenge like this. It looked like I was just running into some kind of a problem with that second loft profile. And hopefully that was insightful to kind of see how I go through and iteratively troubleshoot. If you guys enjoyed that one, put a 1 in the chat. I do appreciate everybody sticking around for that overtime session there. Sometimes things don't go quite as planned, but that's okay. You know, that's what we're learning about here at TooTallToby. We're learning how to get ourselves out of those challenges. So be sure to like, be sure to subscribe, be sure to share and reshare. Visit us over at TooTallToby.com/practice. And let's get into it here with our second answer. This is a pretty fun one. All right, take care, FPV Kev. Thanks for joining us. Good luck on the rest of the day. Let's see who came up with our first answer here in this challenge. The first answer came in at, let's see here. Aaron C comes in 53.9. Very nice. Rambros 53.8. We'll call that 54. Dom is in the chat. What's up, my man? 54 grams. Parge coming in 54 grams. I like these 54s here. Aaron C 54 grams. Parge 54 grams. I like revising, but basically keeping the answer because of the tolerance and precision. And Aaron C coming in with a super chat. Thank you, my friend. Thank you so much. Very much appreciated. A super chat for the happy holidays. That is awesome. Guys, the correct answer to this challenge is 54 grams as expected. So congratulations to anybody who finished that challenge. It's got a sweep in it. It's got a circular pattern in it. It's got a lot of different features in it. Not necessarily an easy challenge. And if you were able to try that challenge and finish it, awesome job. And if you do 3D print it, let me know. You know, send me an image of your final 3D printed model. I'm definitely going to 3D print this one. So let me know. Aaron C gets a clean sweep. Well done, my friend. 2 points for the very first live stream here in December. Well done, my friend. And congratulations to all the winners, which is all of you. Thank you so much to the most amazing chat ever. This was a lot of fun today. Always a fun way to start the week. Don't forget to try to tell at least one coworker about the channel. And please visit us at practicemodels.com. At TooTallToby.com/practice check out the Practice Models app. We're having a lot of fun with that app, with developing that app. We'll see everybody again next week. More CAD versus CAD 3D speed modeling. And I just want to say again, thank you all so much. It's so much fun to join all of you, to chat with all of you, to answer your questions. So if you think of any other questions, feel free to send them to me. You can join us on Discord. You can send them to me in a YouTube comment, or you could even just email me directly. We also have a contact us form at TooTallToby.com. So if you have any other questions you want me to answer next week, let me know. And I want to say thank you all so much for joining us this week. This was a lot of fun. Hope you guys have a great rest of your Monday. I hope you have a great rest of the week. Enjoy the weather if it's nice, and enjoy the weather if it's snowy too. Sometimes it being snowy is nice too. So thank you so much. Glad you guys enjoyed the challenges. Welcome to the channel, Jim Yude from Sweden. Great having you in here today. And thank you all so much for joining us. We'll see everybody next week.